Now, this property can also work for a subtraction, meaning that whatever I take away from one side, I need to take away from the other side as well. So imagine again I have my normal property here, if A equals B. Well, that's the same thing as saying if I have an A take away a C equals a B, as long as I also take away that C. So for example, let's say I have Z plus 1.4 equals 2.06. In this particular case, our first task is to isolate the variable, to get the variable by itself. Now notice I did a couple things. I used a different variable, and that's completely fine. X, Y, or Z are typically the ones we'll see the most. We can also deal with decimals. They don't have to be whole or natural or integer numbers. We can still do the same thing. So in this case, I'm going to have a Z plus 1.4 take away a 1.4 equals 2.06. And according to my rule that I discovered, I better take it away from the other side as well. Because whatever I take away from one side, I need to take away from the other side to maintain my original equality. Then as the process continues along, I have Z equals 2.06, take away 1.4. So Z equals 0.66. And there's my value that makes this original equation true. To check, we can go back to our original equation, which is Z plus 1.4 equals 2.06. I found my value to be Z was 0.66. So I'm going to substitute that in for Z, add that to 1.4, and see if this is a true statement. 0.66 plus 1.4 produces of 2.06, and that equals 2.06. So my check says that it's true that Z equals 0.66. That solution notation is fine. Sometimes you might see the solution written in a solution set, where the solution to this equation in a solution set form is 0.66. But for now, we'll probably see this solution written that way. But I want you to know that we'll discover other ways to write solutions as well. There's not only one way to write a correct solution.